This is being pulled with a velocity u. There's a string, no? The midpoint on the string is held and it's being pulled. Find the velocity of approach of their centers when angle between the thread segments becomes 2 theta. Okay, see now after this what you can do. So this is the velocity of, how do it move? I think it must move like this only, no doubt. I think it's asking this velocity here. How to obtain that one. So I'll take help of the further few diagrams. I'll keenly make observation here. Now this is what the radius, inner radius is R, radius of outer flanks of the bobbin is eta times that of the inner spool. So this is R if you take it. This radius will be eta. You show for any one. Huh? So this is theta, then this should be theta according to the mathematics. So there's a point A, there's a point P, and there's a point P. Now, what is the state of this like a bobbin? Will it roll? No, it's telling, I think somewhere is telling. The bobbins roll. Roll means what? It will have both translation as well as rotational motion. So it will also have now the angular velocity. Get into the problem. What is it? There's a string, no? So the length AP remains constant. Length AP. Length AP of thread. What is telling thread? Length AP of thread must be constant, as it is inextensible. As it is. Bring the constant equation. What is the velocity of point P? Or the speed of point P? Vc plus Vc sine theta. Va should be equal to, or Vp should be equal to Va along line Pa. What is Vp? Vp should be equal to Vc sine theta plus R omega c. Should be equal to, what is Va? Va should be equal to U cos theta. And what is small? And okay, after this we'll go for omega. What is omega? For pure rolling is telling one more. So what should be the velocity of point P1? Should be 0. When it will be 0? When Vc is equal to eta R omega c. So what is omega c? What you can write as Vc by eta R. So Vc sine theta R omega c will be Vc by eta R U cos theta. So R get cancelled. So Vc eta sine theta plus 1 by eta U cos theta. So what is the velocity of center of mass will be eta U cos theta by 1 plus eta sine theta. What is the velocity of approach? 2 Vc. Because they're more opposite to each other, no? So therefore this will become 2 eta U cos theta by, this will be our answer. Just some constraint equation. Like this also can be answered. You have to be careful. Constraint equations can also be set for you. You have to be very alert. This is for rolling, pure rolling. Rolling at ground. Okay, make observation. I'll scroll down. I think I'll come for this one. Unique